Welcome, friends. So, we are at the last chapter of this network theory. We have already covered the most of the topic, so we have only left with this final chapter. This is all about the Fourier series. It's a very important and very interesting as well. What is Fourier series? In short, we can summarize this as Fourier was a French mathematician. He performed his some experiments through which he claimed that any periodic function can be split into three components. Those three components, first component is a DC term, constant term. Second component is actually some cosine terms, and last component is a sine term. So any periodic signal can be split into a DC term, cosine term and sine term. So what is actually those different terms and their individual coefficients, and this so we should evaluate all of this, or we shall see all of those aspects in this chapter, and at the last we will also solve some numerical examples on that. So let us start. So he was a mathematician. He proposed some theory that any periodic signal can be written in this form. So ft is equal to a0 plus summation n from 1 to infinity an cos n omega naught t plus summation n is equal to 1 to infinity bn sin n omega naught t. Okay, so this n is called actually order of harmonics. So you can see this cosine, within this cosine term we have some terms, that means n is equal to 1, n is equal to 2, n is equal to 3 and so on. So when n is equal to 1, then it should be a1 cos omega naught t. When n is equal to 2, so we should have a2 cos 2 omega naught t. So when n is equal to 3, we should have a3 cos 3 omega naught t and so on. And it is same thing, and it is same applies for sine as well. Sine omega naught t, sine 2 omega naught t, sine 3 omega naught t, in this way. So when n is equal to 1, so it becomes, or it is said it is called fundamental component. It is called fundamental component. And when you have n other than 1, they are all called harmonic component. They are all called harmonic component. They are called actually harmonics, right? So what is that fundamental component? Fundamental component is nothing is this. If we draw the sine curve, so this is the fundamental component. The frequency is 50 Hz. So in 1 second it completes 50 cycles. That means that is the meaning of the 50 Hz. Now when n is equal to 2, then it means within that means it will roughly complete 2 cycles within this time. That is why its frequency is double. Now this fundamental frequency is omega 0. Now the frequency becomes 2 times 2 omega naught t. Okay, so let me use some other inks. So Since frequency becomes double, so within the same time span it completes 2 cycles. So that is called 2 omega naught t or 2 omega naught. Now when it is 3 omega naught, within the same time span, it should complete 3 cycles like this. It should complete 3 cycles like this. 3 omega naught it is called. So they are called all harmonic component, right? They are called harmonics. Okay. When n equal to 1, it is called fundamental, and when n other than 1, it's called harmonics. So any periodic function ft can be written as a0, which is a DC term, of course. Then it is the summation of some cosine terms an cos n omega naught t. Within this term we have fundamental as well as cosine terms, and then this same applies for sine. So it will be bn sine n omega naught t. So this is a definition of Fourier series. Okay, according to mathematician Fourier, it is any periodic function can be split into these 3 components: 1, 2, 3. Now you should know what is the value of all these a0, an and bn. We shall do in a moment, but before doing that, first try to understand what is a periodic signal. What is a periodic signal? Now from the definition of periodic signal, it is said that it a signal which repeats itself after a certain interval of time. A signal that repeats itself after a certain interval of time. So mathematically it is written as f t plus t naught, that will be equal to ft. So it is actually repeating itself after this time t naught. So this t naught is actually called time period. T naught is actually called time period, and you know this is some fundamental relation. It will be required quite badly later on of this chapter. So you know omega naught is equal to 2 pi f naught. So f naught you know 2 pi by t naught. So from there omega naught t naught, that should be equal to 2 pi. This is very important. We shall require very badly this thing, omega naught t naught is equal to 2 pi later on this chapter. So here some pictorial representation of some periodic signal. You see everything is repeat after some time, which is called time period. So it is actually the time period t naught. It is repeating itself after t naught amount of time. So this is t naught. Again this is t naught, right? So in this way every signal repeats itself after that time period, at that time which is called the time period of the signal. Now this is a periodic signal. Now if you consider each of one of these signal, then each one of these signal can be split into these 3 forms: a0, this, then an, then bn. Let us try to understand what is a0. What is a0 actually? Then we shall understand what is an, and then we shall understand what is bn, one by one. Now to make this calculation easier for you, let us do some background mathematics. Let us solve some background mathematical result. Okay. So let us say we have a fundamental sine wave. Let us say we have a fundamental sine wave. This is T naught. This is a fundamental sine wave and this is a fundamental cosine wave. Right. Again, it is T naught. T naught is the time period. Now, if we do this thing, integration 0 to T naught sine n omega naught t dt, what will be the result? And similarly, if we calculate 0 to T naught cos n omega naught t dt, what will be the result? So what is actually doing here? N could be anything. It is true for every value of every integer value of n. N is equal to 1, 2, 3. We are showing it for n is equal to 1. But they are true. This result will be true for any value, right? So what is actually this equation is depicting? It is actually summing sine curve over a complete cycle. It is summing the sine curve over a complete cycle from 0 to T naught. So that means if you add them over a complete cycle, what will be the result? The result will be 0. The same will be true for cosine curve. The result will be 0. The reason being, you see, for the positive half cycle, whatever be the area, for the positive half cycle, whatever be the area, it's exactly negative half cycle, the area will be the same. So if you add, then total area will be 0. If you add, that is the total area will be 0. So the summation of the sine curve over a complete cycle, that will be 0. And this is true even for cosine curve as well. This is true for cosine. The same argument applicable for cosine as well. The net positive area, that will be equal and opposite to the net negative area. So that is why, but you must make this integration over a complete cycle from 0 to T naught, or maybe this equation in some form. This equation can also be written as, let us we integrate sine n omega naught t dt. Okay, let us start our integration from any arbitrary time t. Then if you conduct this integration over a time of t naught, t plus t naught, this will also be 0. So these two things are basically same. These two equations basically same. It is 0 to T naught, and this equation tells you from any arbitrary time to T plus T naught time. So basically both these equations are same. So the first equation, this is 0 to T naught sine n omega naught t dt is equal to 0, and thereby we have understood that the same thing applies for cosine as well. 0 to T naught integration cosine n omega naught t 0, that will also be true. Next, if we multiply sine and cosine, sine m omega naught t and cosine n omega naught t. So if you follow the triangular law, so half into 2, so it will be 2 sine cos, 2 sine m omega naught t cosine n omega naught t. So 2 sine cos will be this formula, sine m plus n omega naught t, sine m minus n omega naught t. So applying the same argument, the integration of this sine curve over a complete cycle, it will be 0. And same applies for sine m minus n omega naught t, the same applies, this will be also 0. So if you multiply sine and cosine, so the result will be 0, provided you must conduct the integration over a complete cycle, that is 0 to T naught, where T naught is the time period of the periodic signal. Now let us evaluate two sines multiplied together. two signs, sin m omega naught t, sin n omega naught t. So if you make half into 2, so 2 sin m omega naught t into sin n omega naught t. So this will be the formula cosine m minus n omega naught t minus cosine m plus n omega naught t. Now you will get some different result for these two remaining two expression. Let us explain. Let us try to understand. Now as far as this is concerned, cos m plus n omega naught t, that will be 0. Cos m plus n omega naught t, that will be 0, because integration over a complete cycle over a cosine curve is 0. Now this will also be 0, that means I am writing it separately. 0 to t naught, 0 to t naught cosine m minus n omega naught t. Now what will be the result? Now let us consider m is equal to n and m is equal to not n, right? So when m is equal to n, so this becomes cos 0 actually. So this becomes cos 0. Try to forget to write this dt. Okay. So when this actually m becomes n, then it will be cos 0. So it will be cos 0, that means cos 0 you know 1. Cos 0 1. So this equation becomes integration 0 to t naught only dt. So it will coming out to be as t naught. And you see outside we have half. So we will have t naught by 2. So this is only true for m is equal to n. Other than that, m not equal to n, all will be 0. So please try to understand, whenever m is equal to n, this cos 0 into omega naught t, so this will become cos 0. So cos 0 is 1. So 1 into dt is dt. So integrating dt from 0 to t naught, so it will become t naught by 2 with a half outside. So this result is very important. Please try to understand. So we have m and n. Whenever they are equal, they will give you a result t naught by 2. They will give you a result t naught by 2. Other than that, they will simply 0. Other than that, they will be simply 0. So when two sine terms are multiplied, only one case will be there, only one multiplication will be there, for which it will give t naught by 2. Other than that, all are giving 0. Right? Because simply we have cos m minus m. Whenever m is equal to n, that becomes cos 0, cos 0 becomes 1. So due to that fact, no cosine is there. So only we are integrating dt. Now let us explore the last term. Now if we multiply cosine, two cosines, right? Cos m omega naught t and cos n omega naught t. So if we multiply half into 2, so it will become 2 cosine m omega naught t, and then we have cos n omega naught t. Then if we use that formula, the result is this: cos m plus n omega naught t, it will be simply 0 if we integrate it over a complete cycle, 0 to t. And the second expression, it is again cos m minus n omega naught t. So whenever m is equal to n, we should get this result t naught by 2. We should get this result t naught by 2. Other than that, whenever m not equal to n, this simply goes to be 0. So let us quickly recap. So we have first understood if we integrate only sine curve over a complete cycle, it will give you 0. If you integrate cosine curve over a complete cycle, that will be 0. So if you multiply sine and cosine, then if that product is integrating over a complete cycle, that will also give you 0. Now if you multiply 2 sine, then if you integrate it over a complete cycle, then one term will be there, you will be getting the answer T0 by 2, that is the half of the time period, provided m must be equal to n. And lastly we have for if we product 2 cosines, then if we integrate it over 0 to T0, then for m is equal to n, it will give you a result of T0 by 2. Other than that, it will give you 0. So we require these 5 background results to evaluate the coefficients A0, AN and BN. Okay. So with this background results, so let us first try to evaluate A0. So this is the, you know, this is actually the Fourier series expansion. Ft, that is equal to A0 plus summation n is equal to 1 to infinity an cos n omega naught t plus summation n is equal to 1 to infinity bn sin n omega naught t. So this is the fundamental equation of the Fourier series expansion. Now let us multiply or simply let us integrate this equation over a complete cycle. So we have 4 terms. Left hand side we have 1 term and right hand side we have 3 terms. Let us integrate each term over a complete cycle. 0 to T0, then we integrate 0 to T0 A0 dt, then we integrate this term 0 to T0 an cos n omega naught t dt, and finally we integrate 0 to T0 this sine term dt. So that is the exactly that thing is written in this expression. So now using this background result, we know any cosine term, if it is only cosine, then integrating it over a complete cycle, that will be 0. Any sine term, if it is only present, integrating it over a complete cycle, it will be 0. So what is here? We are having integration 0 to T0 ft t, that will be is equal to integrating 0 to T0 A0 into dt. So A0 is the constant, so you can have the integration dt is T0. So if you, this result will be A0 into T0. So from there you can directly write what is the A0. A0 is nothing but 1 by T0 integration 0 to T0 ft into dt. So that is the value of, or that is the expression of A0 through which or by which we can evaluate A0. So A0 is nothing but it is the actually average value of the function. It is nothing but what is actually saying this equation or this expression, it is denoting, it is the average value of ft. That means we are integrating over a complete cycle 0 to T0, then we are dividing it with the by the entire time period, that indeed is calculating the average value of the function over cycle, over a complete cycle. That is very important, over a complete cycle. That must be, that means these all derivations are based on the integration carried out over a complete cycle. If you don't consider a complete cycle, this calculation will not work. So that is a prerequisite for these calculations. Okay. So what is A0? A0 is nothing but average value of the function ft. So now let us do another thing. So we have ft is equal to A0 plus summation n is equal to 1 to infinity an cos n omega naught t plus summation n is equal to 1 to infinity bn sin n omega naught t. Now what you are doing is that we are multiplying each term with a cosine term. Okay, so let us multiply this with a cosine term and then integrate. So let us multiply each term with a cosine term, right? So if we multiply ft with the cosine term, so it will become ft cos m omega naught t dt, and then we integrate over a complete cycle. After getting multiplied, it should be integrated over a complete cycle. So ft into cos m omega naught t dt. Then term should be multiplied with the cos. So this will be the result, a0 into cos m omega naught t dt, and then it should be integrating from 0 to t naught. And the same thing applies. We have inside the summation cos n omega naught t, with that we have multiplied cos m omega naught t. Then this product should be integrated over a complete cycle 0 to t naught. And finally we have this expression. So if it is multiplied with cos n omega, so we are multiplying this entire equation by cos m omega naught t. So the final expression becomes this cos m omega naught t into this summation term, and then we are integrating this product from 0 to t naught. So let us now apply the previous result. So you see now there is something ft into cos m omega naught t. Okay. Now it is only a cos, so you know the integration over cos is 0. Integration of cosine signal over a complete cycle, it will be 0. Now if we multiply cos and sine, and if we integrate over a complete cycle, it will be 0. We have seen already this result. Sine into cos, it will be giving you 0. So what is actually left in this expression is that, okay, now what happens with this term? What happens with this term? We have cos m omega naught t and cos n omega naught t. Here n varies from 1 to infinity. Okay, so whenever n is equal to m, this will give you value of t naught by 2. Other than that, it will be everything, it will be 0. So actually this equation can be written simply as 0 to t naught ft cosine m omega naught t dt, that will be is equal to a naught or an into t naught by 2. Again I am repeating why this will be actually t naught, because this is only m. However, inside the summation we have n from 1 to up to infinity. Now within that 1, 2, 3 up to infinity we have also m. So whenever m and this m matches, then this product will only be give you t naught by 2. Only t naught by 2, and remaining all other products will be 0 as per this result, right? You see this result. So ultimately this will be, actually there is a this will be accompanied by an and this should be accompanied by a bn. So it should be an into t naught by 2. So finally we will have, what will be the value of an? An is equal to 2 by t naught, and it should be multiplied by 0 to t naught cosine m omega naught t dt. So this is the formula, actually formula of an. So what does it signifies, this equation? It is actually depicting, it is the 2 times the average value, 2 times the average value of ft into cosine n omega naught t. When you multiply this function with the cos n omega naught t, and if you take the average value, it actually represents the 2 times the average value. Now let us evaluate the final term bn. So we will apply the same logic. Now this time we will multiply sine terms. Previously we have multiplied cosine terms, now this time we will multiply the sine terms. So the left hand side will become ft sine m omega naught t dt over a complete cycle, integrating over a complete cycle 0 to t naught. Then coming to a0 into sine m omega naught t, then integrating it over a complete cycle 0 to t naught. Now this is actually sine m omega naught t, then summation an cos n omega naught t dt. Okay, actually this is an, so it should not be there. Okay, so this should not be there. An and bn is already there. So sine m omega naught t into cosine n omega naught t dt. And finally we have multiplied sine omega naught t into bn sine n omega naught t dt. So we will have the similar result. So this will be 0 because integrating over a complete cycle of a sine curve, it is 0. Now if we multiply sine and cos, every time it will be 0. Now inside this summation we have n equal to 1, 2, 3 up to infinity. So within that value we have 1m. So when this m and this m matches, it will be value of t naught by 2. It will be giving you a value of t naught by 2. So it will be actually giving you this result, or summation 0 to t naught ft sine n omega naught t dt, that is equal to bn t naught by 2. Okay, bn t naught by 2, because when m matches with this summation m, then it will give you a value of t naught as per this result. As per this result, when two signs are multiplied, so when m and n equals, then it will give you a value of t naught by 2. So from there we shall evaluate bn, that will be equal to 2 by t naught integration 0 to t naught ft sine n omega naught t dt. This is the expression. So what is actually depicting this equation of bn? It is the 2 times of the average value of this product ft into sine n omega naught t dt. So it is basically 2 times the average value of ft into sine n omega naught t dt. So we have evaluated A0, AN and BN. So what is AN? What is A0? First, it is actually the summation of Ft dt. So it is the average value of Ft we have evaluated. Then we have evaluated AN. It is the 2 times the average value of Ft into cosine term. And finally we have evaluated Bn. So in this way we have evaluated every term that is present. Those are present in the Fourier series expansion A0, AN and Bn, and they are represented by these relations. Okay. So these background results are extremely helpful. This background result, that is why I am focusing, I am giving stress on these 5 results. They are extremely helpful to derive all these results. Okay, so we have derived these 3. So from the next session we shall talk more on that. So if we have a periodic signal, so should we evaluate all those 3, that means A0, AN and Bn, or we have some rule? Suppose if we have certain type of periodic signal, we evaluate A0. If we have another type of periodic signal, we evaluate AN. In this way, so should we evaluate all those coefficients, or there is some rule? So regarding that, it is we shall discuss from the next session. So thank you.